Wi-Fi, protected access, and moving to a AAA server. You and I get to do something different here. What we're going to do is we're going to extend beyond our controller, and we're actually going to start using a AAA server. And the AAA server I'd like to demonstrate for you right now is ICE. That's the Identity Services Engine from Cisco. And ICE is running as a virtual machine. The wireless LAN controller is also running as a virtual machine. The AP is a physical device because I needed the radio. And then for our client, we'll go ahead and use the iPhone. So to make this work, we need to do a couple of things at the controller. We need to tell the controller about this Radius server. So we'll use the Radius protocol between the controller and the AAA server. And we also need to tell the AAA server about this wireless LAN controller, that they should be talking to each other. Then we can create a brand new wireless local area network and simply tell it that we want to use the AAA server for the authentication in the 802.1x. So when the iPhone user connects, the wireless controller will send that request via Radius over to ICE, who will say yes or no. And if it's a yes, the access point and the iPhone can use the pairwise master key and then subsequently create the pairwise transient key, which gets further subdivided for the individual algorithms that are going to be used for the data integrity and the encryption that's about to happen. So when the encryption does happen, one of the questions is where exactly does it take place? It's going to be between the client to the access point right there in our journey. So the access point is responsible for encrypting data going to the client and decrypting data coming from the client. Then when the access point takes all that information, wraps it up, puts a CAP/WAP header, and forwards it through the tunnel to the controller. Then the controller is going to use Radius as it interacts with the AAA server. So even though the specifics of ICE aren't critical for the CCNA and wireless, I would like you to get a little exposure to it, and that's why we're going to use that as our AAA server. So let's begin at the AAA server to begin with, and then we'll work our way over to the controller and then finally test it at the client. So this is the main homepage for the Identity Services Engine, also known as ICE. And this is the name I gave it, ICE, ICE baby. Now we have two basic things we need to do on this device. We need to create some user accounts to test with. And secondly, we need to tell ICE about this wireless LAN controller that's going to be making these requests. So to do that, I'm going to hover over administration. And from this drop-down menu, let's go down to network devices. This is from ICE's perspective, those devices out there that will be making those Radius requests. So we'll click on network devices. And I've currently got a router configured. I did that for testing purposes, just to make sure I had reachability and everything else. And all we need to do is simply add our network device of the wireless LAN controller. So we'll click on add. We'll give it a really cool name. And this doesn't have to match the identical name on that controller, but it couldn't hurt because that way when we see it here in ICE, we'll know exactly which device we're talking about. Description is a wireless LAN controller. The IP address of that guy is 192.168.1.185. Now that's the service port address. Now regarding the wireless LAN controller, it's got the service port, it's got the management interface. The service port is 192.168.1.185. And the management interface is on the 10 VLAN, it's 172.16.10.5. The management interface is the interface that the controller is going to use to communicate and talk with the access points. When the wireless LAN controller makes a request for Radius, it actually used the source IP address of its service port. So when we define the controller here in ICE, we're going to tell it to go ahead and use the 192.168.1.185 because that's the IP address in measurable terms that this virtual wireless controller is going to be using to send those Radius requests. So we can actually create network device groups. For example, devices that have similar characteristics or similar needs or similar treatment, and we can put those into groups. This is a very generic vanilla implementation of ICE. And I'm just going to go ahead and use the defaults to say the location of this controller is all locations, and it's going to fall into the device type called all device types. So I'm going to scroll down just a little bit more, and let's set up our authentication settings. So here we're going to say, okay, for Radius, which is the protocol we're going to use, we want the shared secret to be, and I'm going to put in Cisco. Now what this password does is when Bob authenticates, his password is sent from the wireless LAN controller, of course, through the AP, and it's being sent via Radius now over to ICE. So the entire session by default between the wireless controller and ICE, it's not encrypted. However, the password of the user is. So somebody eavesdropping that isn't going to be able to determine what the password is. So we're going to want to have the same shared secret from a Radius perspective on the wireless controller and ICE, just for the benefit of their Radius session going back and forth. So if that's all we need, and I think it is, I'm going to go ahead and click on submit, and that will save those changes. And we got a little pop-up right here saying the changes have been saved. Fantastic. The second thing that we really ought to do while we're here is create a user account for Bob. Now we have Bob locally defined over on the wireless controller. So what I'd like to do is let's create a different username. That way we can verify that yes, the authentication is happening where we think it's happening. And we have two different usernames, one locally and then one here up on ICE. That'll be easier to see. So to do that, we'll hover back over here on administration. We'll go to identities, click on that. And I have no users here, so let's go ahead and create Bob. In fact, we're going to call Bob ICE Bob. And I'm not going to put an email address in, but I will put in a password. I'm going to use Cisco 123 with an uppercase C in Cisco. The default policy in ICE, you can change it, but the default policy is to have some complexity, and that's why I'm using the capital C and 123 at the end. You can add other details if you'd like. However, I'm going to go ahead and simply submit this, because all we really need is ICE Bob. All right, so Bob's ready. The identity services engine knows about the actual controller. Now let's make a road trip over to the controller to tell the controller about ICE. So here on the controller, if we want to specify the IP addresses of AAA servers, specifically Radius servers that we're going to use, we'd go to the security option here. And on the left-hand side, under AAA and Radius, we'd simply click on authentication. So we're at security, and then underneath Radius, we have authentication. Here's our little breadcrumbs to tell us exactly where we are. And you'll notice we don't have any Radius servers defined by default, but we can fix that up in the upper right-hand corner. We'll simply click on New, and we'll put in the details of that ICE server. So Wireless LAN Controller 1 is at 185. Wireless LAN Controller 2 is at 186. And the interface for ICE is at 187. Now it needs the shared secret. So that is Cisco, all in lowercase. And that is, again, for the benefit of just that Radius conversation between this controller and the AAA server. There's our default port of 1812. We can leave that because it'll work. And we'll click on apply up here in the upper right-hand corner. Cool. Now, just for grins, if we wanted to make sure we could, at least communicate at an IP level up to that device, we could do a ping, and it says, okay, congratulations, we received 3. We sent 3, and we got 3. That's good news. Now, does that mean everything else is dialed in perfect? No, but it's a good sign that we have some basic connectivity to the IP address, and that is a good indicator. Now, previously, on this same security page, we created local users, and we also specified local EAP. But we're not going to be using local users, and we're not going to be using any kind of local EAP, because with 802.1x, with EAP, we're going to send those requests over to that AAA server and ask him, the AAA server, whether or not Bob's username and password are correct. So let's go and create a brand new wireless local area network just for testing our Radius. So to do that, we'll leave all our others intact, and let's go ahead and click on Go to create a brand new wireless local area network. And for a profile name, let's call this Radius-ICE. And for the SSID, we'll call it Radius-ISE, just so we know what it is. Now, the name itself, of course, doesn't control the fact that we're going to be using Radius. That comes up next once we click on Apply, and then we go to Security. So right here, it says by default, it's going to be using WPA2 and 802.1x. However, we do want to enable this wireless local area network, and I want to play up in the 802.11 ranges only, and we'll put them on VLAN 30 as well. So what's going to happen is when Bob connects, the ICE Bob connects, he is going to be logically associated with VLAN 30. Now, there is an option under security where we can say, you know what? We want to override this interface that the controller currently wants to go ahead and put them on. If we choose the overwrite option, and the AAA server has been configured, say, you know what? Bob deserves to be in VLAN 20, not VLAN 30. So if the AAA server has configured a specific VLAN that Bob should be a part of, and we enable the overwrite option, the information from the AAA server would overwrite the defaults associated with this wireless local area network. So let's take a look at the security tab, second from the left. So from the drop-down, we have lots of cool options. The default being WPA and WPA2, meaning it's willing to go either way. So for the WPA and WPA2 parameters, we can mix and match. So for example, if we wanted to also include TKIP as part of WPA2, we could. It's off by default, but we can mix and match and set these up the way that we wanted to for our environment. I'm thinking that WPA2 encryption with AES is probably more than adequate. Also right here is showing us that for key management, we're using 802.1x. And now we need to specify which AAA server we're going to use for that authentication. So for this wireless network, under the security tab, we're going to go to the AAA servers sub-tab on the far right. And what we're going to do is we're going to say, okay, server 1, and then we pick from the list. So if we had 20 or 30 different AAA servers, we'd simply pick from the list here. Notice it includes the port as a reference. And if that AAA server had been configured with specifics for what VLAN and so forth a user should go into, if we click this checkbox right here, that's what causes the information learned via radius from the AAA server instead of using what's configured by default, which is VLAN 30, for this wireless local area network. Now, if we scroll down a little bit, we don't need to do the local EAP authentication because we're not going to do it at the controller. We're going to pass all that stuff over to the AAA server. So I'm going to go ahead and click on Apply, and let's bring up Insider just to verify that that wireless network is live. So there it is, Radius ISE. It is currently active and available. Let's go ahead and connect to it from a client. So from our client, we look at the wireless networks available. We select the Radius ISE. It prompts us for username and password. We click on join, and then it says, warning, Will Robinson, because we've received a cert which we cannot verify. It's been signed by some certificate authority that we don't trust. So if we click on accept, it then proceeds to go ahead and connect us to that wireless local area network. In the background, the authentication has been done by our AAA server, the Identity Services Engine. From the monitor screen, we can go down to clients, take a closer look at the details of this recently authenticated client by clicking on its MAC address. So here we have the username, IceBob, which doesn't exist at the local controller. It only exists up on the AAA server. And if we scroll down, we can notice that we're using AES CCMP. That would mean WPA2 or 802.11i because they both call for that. And the EAP type is protected EAP with the certificate at the server, the self-signed certificate in this case, and the user proving its identity through a username and password. Sometimes having a second confirmation of something that's working is a great thing, and to do that, we could go back to ICE under reporting, and in the last hour, we have 4 separate authentications from this user called IceBob. And that's because I ran it through its paces a couple times before I did the nugget with you, and then I logged off and logged back in before we went to the monitor page to take a look at the details of the client. So it also confirms that it's using protected EAP, and there's the network device, the controller, that made the request. In this video, we moved the authentication responsibilities from the controller out to a legitimate AAA server. In our example, we used ICE. I hope this has been informative for you, and I'd like to thank you for viewing.